normal game of Go, right, where you start playing and you realize you lose. So actually I had a few demos I wanted to show.
Okay,
Let me just pull this, and I don't know if they're broadcasting.
Oh, right here.
Perfect.
All right. So you can actually see this presentation. So let's see. Does this do what it should? Maybe. Okay. Wow. So technology actually works. That's what. Who would have thought? All right. So as maybe some of you, this is kind of weird.
If I just speak like this, can everyone hear me? Okay, if you don't mind, I might just speak like this. I can leave the mic here so that hopefully people who are following online can hear me. Sorry. Okay, sorry, the echo from that was just like really jarring. But I'm loud, I can speak loudly, so hopefully everyone can hear me. And if you can't, just feel free to yell at me or throw a shoe or something at me, and I guess I'll speak up. So actually, just before we start, I want to get a show of hands. How many folks here are students? Okay, cool. So it looks like a majority. And what how many of you are undergrads? Okay, and then master students, PhDs, or postdocs, or whatever. And then how many folks here are from industry? Okay. All right. Cool. All right. I just want to get a sense of my audience. So I guess I might as well introduce myself now that I've asked you guys about who you are. So, like perhaps many of the people in this room, I'm a recovering academic. And you know, I have this sort of whole long rehab process where I went from being a quant on Wall Street to moving out to the Valley and working briefly at a VC, Andreessen Horowitz. Spent some. Somebody's really a fan of A16Z. Then moved over to Foursquare, where I did monetization and data science, and then eventually founded the Data Incubator. So we are a 7-week fellowship for PhDs and master's students for careers in data science and as quants. And kind of the way the program works is that we attract over 1,000 applicants. We screen them, interview them, look at their code, so really do a fine-grained assessment. We take the top 3%, and then we train them. We sort of train them in all the big data technologies that you might know and love, like MapReduce, or Spark, or Scalding. A bunch of machine learning techniques, so like NLP, random forests, K-means, data visualization stuff like Matplotlib or D3. And then, of course, after we train them, we work with a bunch of hiring partners. You can see some of the ones up there, so like Booz Allen's and Palantir's of the world. And we hope to get them placed. And the program's completely free for fellows. And we did it that way so that we could sort of attract the most amount of talent. Because, well, there's obviously huge growth in data science. You can see sort of on the right, that's the number of self-described data scientists according to LinkedIn. So this exponential growth. And as you can imagine, there's probably a lot of charlatans. Certainly at least a lot of rebranding going on. You know, there's a classic joke that what is a data scientist? Well, it's just a statistician who moved to Silicon Valley and is still under 30. And I think we find this a lot with, in my experience at Foursquare when I was interviewing, that you often interview people, but they kind of turn out, they look good on paper, but they kind of turn out to be done. So we wanted to build something that would kind of streamline that process, find the really good people so that they can shine, and then and work with them, train them, give them some skills so they can be more productive on day one. So if you are looking to hire, you should email John. But that was the sales pitch. The rest of this talk, I actually thought I would say a little bit about data science projects. So as I said, we have all these fellows, they come through, and what they do when they come to the data incubator is that they work on these little mini projects. And I'm going to skip that one. So, there are often projects that combine a little bit of data science, a little bit of engineering, and some sort of like practical, real-world question. So this is where I'm going to see if the other piece of technology I have works. It's called the internet. Can you guys all see? All right, can you guys all see? So I'm just going to sort of give you a few of these projects, because I figure you're going to be spending the next 48 hours hacking away, doing some interesting stuff, and maybe you would like some inspiration on what are some interesting projects that our fellows have been doing. So I think all of us here are basically from New York or the New York area. We probably all take a taxi. We probably all tried to hail a taxi. And we've probably all been in that horrible situation where you're standing there, the taxis don't come, or the taxis do come, but they're always full of people. Well, it turns out that New York City has recently released a whole data set. It's 160 million trips that happened in 2013. Start location, end location of all those trips. And one of our fellows, Will, decided to do this analysis of this data set. And it's actually meant to be like a little mobile app. So if you click on Find a Taxi, Cornell is going to ask me for my password. I happen to know that Google will give me free internet. So the Google works. Let's try that again. Amazing. Okay, so depending on how long the GPS takes to geolocate me, it should figure out that I am here in Chelsea. This is more or less the building, the Google building. And it's really interesting because when I did this just like, I don't know, 10 minutes ago, I was over on the other side of Cornell Tech, and it actually gave me very different results, which are more interesting to talk about than these, but that's fine. So these are the top 7 or 8 locations in intersections that are nearby here, which are the best locations to go to if you want to hail a taxi. And this is actually somewhat underwhelming because all the locations are just on 8th Avenue, which is probably what you would have done anyways. But if I was just over on that side of the building, what it would actually do is give me a few locations on 9th Avenue. And it's because, actually you can see it if you click here, what it's doing is it's taking the amount of time that you would take to walk to that location and adding it to an estimate from the data now of how much time you have to spend waiting at that location. Adding those two up and giving you a total wait time. Sorry, my moving the mouse is not going to tell anyone anything, is it? So let's see if this works. Maybe? No? Okay, whatever. It's taking this column, adding that column, and getting that column. And that's what goes into the model. It goes to the ranking of which intersections are better. And it's really interesting, right? So, for example, in my neighborhood, I live in Brooklyn Heights, there are 2 streets that I sort of straddle. And one street is Clinton, and the other street is, I don't even remember what the other street is, but it turns out that Clinton is a much better street to go hail a taxi on. According to me, you can actually basically never hail a taxi on Henry, that's it. And that actually really kind of confirms like my own experiences trying to hail a taxi in my neighborhood. I always go to Clinton Street. Let's see. So Will's also done some really interesting analysis on the data. It's more than just sort of an app. All right, maybe I can make this a little smaller. So here are the top, I think there's like 1,000-some intersections in New York, and here he's ranked them from the easiest to hail a taxi at to the hardest. And the easiest ones, you kind of see on the map here, are all near Penn Station. Then if I can reverse the list, so near 2000, this is the worst intersection to hail a taxi at in all of New York, or well, at least in all of New York for which taxis are actually hailable from. This is actually on 100th Street in the Upper East Side, or really by Spanish Harlem. And you really can't get a taxi there. The pickup wait times are pretty bad. And I don't know how many people here, how many people here like live in the Upper East or like in Spanish Harlem? 1, 2, okay, so a few folks. So I used to live up there at one point in my life, and I was on like 98th Street, and you would look south towards 96, and you would see the taxis coming up the avenue, and it was like Moses parting the Red Sea, right? Like taxis go left, they go right, but none of them will actually go past that 96th Street barrier, even though I'm standing here like furiously waiting with my luggage coming into the morning, right? They just refuse to go, and I have to like walk 2 blocks to go south. And you can see that in the data, right? If you look here, I guess it's a little hard to see, but like all those dots are where you can actually hail taxis, and things north of that aren't. And that's roughly 96th Street right there on the east side. Yeah?
Is this data only from based off of 2013?
I think this is, yeah, I think
So it's
2013 maybe.
last year.
Oh yeah, so this is only yellow taxis, so it doesn't include the green taxis. That's what you're asking. In fact, if you look at the map, you basically can only, there's only data from like Manhattan, the wealthier parts of Manhattan, and like the 2 airports.
This is one static analysis over like the course of the year, just that entire year. So this is going to take into account at the time.
Yeah, so actually you can even look at the time of day. So that's what this chart is. So it's showing, maybe it would make, well, anyways, it's a chart. It's showing the drop-off rates and the pickup rates at different times of the day. And of course, in the model that he's building to actually predict the drop-offs and pickups, those are all used, that uses 4 factors. I think it's like time of day, day of week, proximity to the intersection, and the ratio of drop-offs and pickups. So it uses all that kind of data that you might expect. The other cool thing you can do is run some k-means clustering. So I don't know if you're familiar with non-parametrics of statistics, or sorry, unsupervised learning, but you can do a little bit of that. And so you're basically throwing in those graphs that I showed you of the drop-off and pickup intensities. You throw those through time series into your sort of cluster curve, and out comes some of these colors. And so obviously each color is a cluster, and you can actually see a lot of patterns in here. So let me try to zoom in. The red dots are near subway stations. The blue dots are, oh, maybe it's clearer when you zoom out. The blue dots are in residential neighborhoods, and then there are these green dots, which are rare, but they're like right here at Penn Station. If you zoom out, and also like right here at the 2 airports. So somehow, by looking at the pattern of pickups and drop-offs of taxis, you can kind of get a sense of the topography, the commercial and residential topography of the city. And I think that's really cool. So we're talking about sort of hailing taxis in New York, but of course data science can do a lot more than just helping you hail a taxi, right? So here we have a project by another fellow, Matia, and he's looking at predicting real estate prices from crime data. So this is in the city of Chicago, not too far from here. Okay. All right, so here you have a map of the city. This is each of those kind of cells is a zip code, and the coloring is the price of a 2-bedroom apartment. So you can see that here in the center of the city, the average 2-bedroom apartment might be close to $1 million, and out. I click. Here in the edge of the city, you can actually, well, this is the south side of Chicago. You get a 2-bedroom unit for under $100,000. You can also sort of do the scrolling bar back and forth, so you can see how, oh, you can overlay this with homicide, so each little red dot represents a homicide. And you can really see how both the homicides change that year and the housing prices change from year to year. But of course, I guess no project is complete unless you do some sort of unsupervised learning. So here he's taken a whole bunch of factors, so the crime, but also things about commute time from each of these zip codes, and he's thrown that into a clustering algorithm, and he's gotten out, as he says, it's k-means here, and he's gotten out these 4 clusters. So you have, let's see, so it's really cool because when you move your mouse over, you can see that on the, yeah, you can see that on the screen, right? It's sort of showing you where it falls on the graph. So on the right here, it's just the coloring of where the clusters are. And on the left, you have the prices along the x-axis, which, can you see my mouse? No, you can't. On the left, you have the x-axis, and across the, so you have the housing price, and across the x-axis, you have crimes that's normalized by population. You can also move across, so instead of looking at all crimes, you can look at just thefts, or assaults, or homicides, and you get a sense that, like, for example, there's a really strong negative correlation between housing price and assaults, but there is perhaps less of a correlation with the number of thefts that occur. And so I think this is really cool, and you can do all this stuff and generate a predictive model to show that these, 6 factors really explain about 85% of the variation in housing prices in Chicago. And I also love this thing. So, all I'm going to show you is like the very the tip of the iceberg. There's a lot that's going on underneath the ocean. So this is kind of that flow of the projects. So, he's getting data from a million data records from the city of Chicago, so all the crimes that happened in, 2014 or whatever that was. He's also looking at the Truly API and grabbing all the housing prices, using OpenStreetMap to do reverse geocoding, because you all have to do that, mashing up with Python, and then using scikit-learn to do all his machine learning analysis. And of course, the part that you probably are drawn to, he just puts out all the V3s to make it really pretty and shiny. Now, I want to move on from sort of violence that happens in America to violence that happens overseas. So this is a really cool project where one of our fellows, she wanted to look at the Iraq War and kind of use data science to try to understand journalism, history, warfare. And this is from a data set of 500,000 memos written by State Department officials, which painstakingly detail the violence happening at a very granular level in Iraq from 2004 to 2010. So you have, and so you can sort of pull up the spatial signature here on the left and the temporal signature on the right, and you can see that a lot of the, overall, right, a lot of the violence is happening around, I think what the commentators call the Sunni triangle, so these kind of Sunni-dominated areas here, and you can see that this graph, like just the number of occurrences of violent events, violence really goes up in 2006 to 2007. This is sort of the Sunni insurgency and sort of a big rebellion that was happening at that time. And then in 2007, with the introduction of the surge, right, David Petraeus' strategy, that kind of really gets squashed out with the introduction of like 30,000 to 40,000 American soldiers. And of course, you can also do a month-by-month scroll and see the number of, the map on the left is changing, but you can see sort of the distribution of violence across the country at different points in time. Of course, you can always just look at how these events fluctuate with days of the week and months of the year. And I think the really interesting thing, you can't quite make it out of this graph, is that there's actually slightly fewer violent incidents on Friday, because Friday is sort of the Muslim Sabbath. So a lot of people are going to pray and hopefully not shooting at each other or Americans. And like I said, no project is complete unless you use some sort of unsupervised machine learning. So she looked at using non-negative matrix factorization. So this is, it's not certainly PCA, I don't know how many people here know about principal component analysis, but sort of like that, except that the components you pull out aren't necessarily orthogonal, but they're often more interpretable because they're non-negative. You look at each of these components that you're pulling out as like a headline story, right? So each of these is telling you a headline story about what's been happening in Iraq over the last 6 years, and they all have a spatial signature and a temporal signature. So this very first one, the headline would probably read, violence happens in urban areas, right? If you look at the map where you see the big red dots, those are the 3 major cities in Iraq: Mosul, Baghdad, and Basra. And then you can see the kind of timeline of violence associated with that. And it has a very unique signature. And that's different from the second component, which is basically violence associated with clashes between Sunnis and Kurds in the north. You can kind of tell because it happened in those provinces that are the border between the Sunni populated regions and the Kurdish populated regions. And this also has a very different temporal signature, which is the thing you see on the right. And then the last kind of headline story, if you will, the last component, is about violence between the Shia and the Sunnis. And a lot of this is actually happening in the predominantly Sunni areas. If you know something about the politics of Iraq in the last decade or so, many Sunnis would probably argue that it's, they used to be in power, now they're not, and so they're sort of fighting a lot of the kind of central Shia government, and they're doing a lot of that in their own home provinces. And you can see there's this gradual ramp up in violence in 2004 to 2007, and then it kind of gets washed out when the U.S. sends, 40,000, whatever number of soldiers in the surge. So I think this is, and then there's one last incident. So there's one last analysis, which is using adaptive kernel regression. So you're really taking a look at the number of events that are happening, and you want to see whether or not the number of other events is more than the number immediately before and immediately after. And what's really cool about this is that you can, so this dotted line is like a 95% confidence interval, and the points above are really like spikes in violence. And these spikes actually correspond to the news stories you've heard. So this first spike is the trials of Saddam Hussein. And this other spike here is it's Muhammad al-Sadr. So there's this like firebrand Shiite cleric who was holed up in Basra for a while, and the Iraqi security forces surrounded his mosque in Basra and started shelling him until he surrendered. So those are all the reports from that. But it's really interesting that you can sort of use all this machine learning to pull out these narratives that these headlines that are off work that you already know, and it all comes from math. So let me, all right. So there's a few more projects, but I think in the interest of time, I will skip them. And I will just sort of go back. Wow, they're slow. I'll just go back to sort of like final slide. If you're interested and you want to learn more about data science, you should go to our blog. It's just blog.dataincubator.com. We're going to be taking a lot of these projects that we've been doing, that our fellows have been doing, and publishing them online. So feel free to head over there. You can follow us on Twitter if you'd like, and we'll sort of be syndicating these out on a regular basis. And of course, if you're hiring, you should email John at the Data Incubator. Cool. Does anyone have any questions?
I was curious about the selection criteria for the actual data set that you used to begin with. So in the case of Trulia, it was pretty obvious that they have a complete repository of housing information, but in the case of crime, you chose to go with government memos. So what makes you pick one data set over the other to validate against multiple data sets?
Well, that's a really great question. So for those who didn't hear, this is about like how do you choose a data set, how do you identify the data sets, and how do you go about thinking about validating between the data sets. So first of all, I should say I didn't do any of these projects, right? These are all done by fellows, so I can't really speak for them. But when you think about, when I think about kind of the data sets I would choose, I think a lot of that is this. Remember that Venn diagram that Hillary put up, where it's like math, code, and then something else? Well, the question you ask basically falls in that something else category, right? It's that part of being a data scientist which isn't the technical aspect. And it's thinking about how reliable is this data source? Do you trust it? So maybe in the case of the Chicago data or the Iraq data, well, those are both institutions, right? The Chicago PD and the U.S. State Department that have vested interest in really well-documented records of the crime or the violence that's happening in these associated geographies. So maybe, it's not perfect, right? Nothing is perfect, but maybe that's pretty good and maybe one of the more authoritative sources you can get. But even if you look at these data sets, there are certainly flaws. Like, one thing you'll notice is that in the Chicago data sets, they will say, here's a crime, it was reported, and year, and then whether or not there was a bust made, or whether or not there was an arrest made. And you'll notice that, for homicide, it's going to be 50% or whatever. For thefts, it'll be 20%. And then for drug crimes, it's 100%. Right? Like, the Chicago PD is so good that they bust every single incident of a drug violation that happens. Do you believe that? Well, I mean, if you think about it, what's really going on is that the only ones they know about are the ones that they busted, right? Because people don't report drug crimes, really, right? So it's not like a murder where there's a sort of this third victim here who has a family that reported this, So there's like reporting biases that you see in the data, and I think it's just something you have to always be cognizant of. Sorry, I wish I could just tell you, like, run it through a random forest algorithm. You'll find the answer, but unfortunately, it requires actually thinking about things more broadly.
If everyone has a taxi entity, and the entity told them to go to the same place to take the taxi, really actually makes it harder to take taxi?
Yeah, that's a good question, right? I mean, and that's another really great point. We often forget that we live in sort of this adaptive system, right? And so as the hailers, the riders of the taxis change their behavior, so do the taxi drivers. They will change their response. So it's hard to really understand what's going to happen in these things when they get to be, a huge scale. Unfortunately, I don't think very many people use this little app that Will built because, build something that he shares with a few employers and a handful of friends. But you're totally right. What's the effect of Waze on traffic in California, right? If Waze says the street is empty, does everyone then clog that street? I don't know. You have to ask them. Sorry, yeah?
How are your fellows choosing which problems to tackle?
Okay, so the question is, how are our fellows choosing which problems to tackle? I think that a lot of it is just very personal, right? So it's probably what you're going to be doing the next few hours as you're choosing a project. You're just thinking about what's a question I'm interested in? What do I want to spend a few weeks of my life doing? And then they just sort of go around online and find a data set that will maybe help them answer that question. Sorry.
Thanks for the great presentation. So I just wanted to comment that on the Iraq War data science, I think it's both remarkable about the power of data science and a sad state of our media, that I feel like I've learned more about some of the cultural and ethnic geographic issues right there. And the things I wanted to ask you about were what that means about literacy of data science in the public, or maybe emerging new tools. That's the first thing. And the second thing is about the supply and demand for data scientists that you're seeing going forward. You can include what you've been seeing with your firm as well.
Yeah.
So two big things you could focus on.
Okay. So
So
you want me
literacy.
to solve data science and scientific literacy, and say something about the supply and demand of data scientists. So maybe I'll do the latter because that's easier to answer. So we work with a whole bunch of companies, and I think we see a lot of growth in some of the areas that Hillary mentioned, right? Healthcare, there's a lot of interest in data science. In banking, actually, and insurance, there's actually a huge growth because there's a big push towards doing more regulation from the various laws that have been passed and been enacted recently, and that's kind of pushed a larger emphasis on the regulatory apparatuses within the regulators themselves and the banks. So you see a lot of hiring for data scientists there. And
Do you feel like
that's obviously the tech sector, right? Tons of money going into Silicon Valley. We see a lot of growth in there.
Yeah, do you feel like, because there's the McKinsey report on big data, and they're projecting that the demand for data scientists is going to grow faster than the supply. Are you seeing that?
Yeah.
Yeah.
And I think if you talk to most people here who are hiring for people, they would probably say the same thing. And that's sort of our business thesis. If there was an oversupply of well-trained data scientists, we would need data science training programs. So
you mentioned when you were hiring, a lot of that.
Sorry, I guess I should have been more clear. So, and I don't know, I suspect this is a sentiment that a lot of people who are hiring managers have had. You will read a resume, they will have they'll check all the right boxes, right? Be like, this person should be really smart, and somehow when you talk to them, they don't quite live up to expectations. So that's what I meant. That happens a lot.
There's no specific skills that they're presenting or anything. Like this was
Sometimes there's, yeah, so I mean, I guess we say this, we tell this to our fellows, but I guess I might as well say this here. If you put something on a resume, you should be prepared to defend it. And the line, oh, I did that 4 years ago for one class, is not really going to cut it. So, yeah.
How do you validate for yourself that your education is preparing you to be a non-good employee?
Well, we actually have a really quite robust feedback mechanism in that our fellows will get placed afterwards, so we track those kinds of cases.
I meant for, it seems like if you get into your program, that's validation in and of itself.
Sorry, so
97%. Yeah, the 97%.
I'm sorry, and your question is?
How do you validate that your education is preparing you to be able to succeed in the world and not be a good?
Yeah, so I mean, like I said, one thing we have to do is make sure that our fellows get placed, so that's a major milestone. And then we're only about a year old, but after a few years, we'll be able to track the progress of our fellows and look at their career trajectories and see how they do. That's a really good question.
Okay, I had meant you as in how we would want one of us, not your fellows, but like everybody else, the 97.
What should students be doing like, in general to get
So
to
you mean
be a fellow?
So you're asking like how do you become a fellow or learn to be a data scientist?
Literally, how do I validate that my education is preparing me to be an adequate data scientist?
Okay, I see. Well, I guess you could apply the same test, right? And see like if you can get higher. I mean, I think ultimately it's really tough. We live in data science is just a constantly evolving field. There's new technologies coming out, and it's tough for academic institutions and even us to keep track and keep pace with all the innovation that's happening in the open source community and in the vendor community. So I think it is a really tall order. You're right. But I don't know, I'm a man who believes in realistic and unambiguous litmus test or metrics, let's say, and being able to get hired is a pretty good one. I mean, your own end is going to be very small for you, so I wish I could give you a better thing. I guess you could maybe hacker rank will do something, or like rank you, and that might be a realistic one. Sorry.
I think it's a good one. We see if you can get a higher one, that's sufficient. But I meant in terms of retention.
I think you could also be, yeah, in a data science hackathon, take first place, put it on your resume, maybe just really impress the judges or the mentors, right? Walk out with a job. Yeah, I think that would work.
Yeah. I wish I could give you a better
I
feedback.
think it's a great one. We're going to hackathon, get a job.
I think
I think for about 8:20.
Sorry, all right. Unfortunately, I will have to wrap it up, but feel free to come bug me afterwards. I'll be here for a